Good day all. Okay, now we have a question under feedback control system. Our question says a unity feedback control system has an open loop transfer function. Determine A, the closed loop transfer function of the system, and B, the system pole in the closed loop configuration. Given that your G of S is 10 over S bracket S plus 2. Okay. Oh, the grammar. Okay. So from what our question is saying here, this first phrase here, unity feedback. What this means is that we are having a this is an open loop control system. C of S represents your output and R of S represents your input. Now here is plus, here is minus. Now let's say we are tapping from here. Our branching point is coming from there. Now at this place we're not going to be having any function, or if we have our, it's either you represent it like that, or whatever you choose, but they are all what correct. It's either you just make it a closed loop, just kind of make it just a feedback loop without adding any function, or you add your function and also indicate that your h is equal to what 1. So the question is telling us a unity feedback. What unity feedback means is that our h value is what 1. That's the need for the unity control system has an open loop transfer function. This is our open loop, where the closed loop started from was from this branching point. This was what formed the closed loop, but only just this straight line is our open loop, and they're telling us that the transfer function on just that straight line is this. So we're not given that our G of S over here is what 10 over S bracket S plus 2, right? Okay, now they say we should not determine what the closed loop transfer function of the system. That was the first thing. And second one is now for us to now find the pole. Okay, now from the diagram, I hope you understood the diagram. So from here now we're going to be making use of our formula. Let me shrink the diagram first. Okay, now from here we're going to be making use of our closed loop formula, which is that the ratio of your C of S over R of S is given to you as what your G of S, your normal closed loop formula that we normally make use of. Since here is minus, here will be plus. We normally make use in our block diagram. So this is the formula we are going to be making use of. Now we are told that our G of S is what 10 over S bracket S plus 2. And we also told that our H of S is equal to what 1 due to this statement there. Now with this we can now write this expression to be this. Right, our H is 1, our G of S, and that. Now solving all through, we're going to be having focusing on the denominator first. Let's focus on the denominator. Let's make it to have the same denominator. So on this one, let us make it to have one denominator. We're going to be having a common LCM of what S bracket s plus what? 2. Now 1 divided by this is this times 1, and how you choose to put it. This times 1, we have s plus what? We have s bracket s plus 2, then plus what? Now this one 10 divided by, sorry, let's say 10. S bracket this divided by this, we have 1. 1 times 10, we have what? 10. So our normal LCM, what I did here, this is over 1. So 1 divided by this times this, we have this. This divided by this, 1 times 10, we have this. So we have not made it now to have equal words. This denominator not to be separate, not to one. We don't want one to be on its own. We want to just join everything together, and this is what we have gotten. Now we can now rewrite this to be this. Right? This and this are the same thing. Now, changing this division sign to multiplication, we have this one will go up, the other one will come down. These two are like them, so they can cancel out. So at the end of the whole drama, we have that 10 over what? S bracket S plus 2 plus what? 10. So this, or you can still go further to also open this bracket. But anyway you stop, is still correct. So this is the closed loop what? Transfer function. This is the what? The closed loop transfer function. So we have just answered for what? For A. So this is the ratio of C of S to what? R of S. We have gotten that. Now the next thing they're not demanding from us is to get the what? The system's what? Pole. Now the system pole that they're talking about is that of the what? Closed loop. You should become careful of this. There's a difference between your closed loop and what? Open loop. They're not the same thing. This is your open loop transfer function, the one that doesn't have feedback. But so long you have added the thing a feedback, is now closed loop. Now in this case, told us our function here is what? 1. Our h there is what? 1. And we have solved it and we have gotten this. Now, before I go into answering B, I would also like to also say this. This system I'm saying now is only unique to Unity and feedback. And a shortcut that you can actually use if the whole process of writing this whole thing down will kind of waste your time. So long as you know it is what? Unity feedback. The answer is directly just you bringing down, adding your 10 to the denominator. That's just all you have to do. This only works for what? Unity word feedback. So just add the value of your numerator to your denominator and you've gotten your answer. If you see, it's just the same thing. But this is only what unique to what? Unity feedback. Another thing again that you also have to watch for this thing to be possible is that your open loop transfer function, which is this one, has to be in this kind of fraction form for this to go. So the reason I'm saying this is because this will also come up when we'll be treating frequency response. We'll be treating frequency response. For instance, we call this a two-order control system. When we'll be treating, we have something like W of Wn of this over the same thing. Let's say something like this too. Say plus 2. Something of this nature is now given to you now. Again, to find, and I tell you that you also have what? Unity feedback loop. The same thing again will also happen. You just add this to just this. Exactly Wn squared. Just add it to this. So there's no need for you solving we'll start deriving the whole thing. It's quite easy. Remember, the only two requirements for this to be possible is that your feedback control function must be what? Unity. That means H must be what? 1. That's the one condition. Another condition is that your open loop transfer function, which is this, given to us, must be expressed in the form of the fraction. That is 10 over something for this to what? To work. Now, with that aside, they say we should find the what? The poles of the closed loop configuration. Our closed loop answer was this. So this is what we have gotten. Now the issue now is, now what do they mean by the system what? Pole. Now whenever you are giving a function a over what? B, the one on top represents what we call zeros. Actually, we say the polynomial on top represents zeros. When I say polynomial, that is like ax raised to power 3 plus bx raised to power something like that. Like when I say polynomial, you know what I mean now? It can be quadratic, but it has to be can be it's like this. But whatever function that is on top, we call them what? Zeros, and the ones down we call them what? Poles. So you can, for you not to forget it, just simply say zeros over what? Pole, z over p. So for you not to forget it, you cannot say z over what? Over p, z over p. So which is what? Zeros over what? Pole. So in this case, our poles is now what? The poles of our closed loop function is given to us as this. Right? So when the poles now that are demanding from us is now to find the value of x of s. So since this is a quadratic equation, that means we are going to be having two values of what? S. You can use a calculator to solve it if you want, or you can still use your almighty formula, whatever you choose to use. All good. So if we are to solve using the almighty formula, we have which is minus b plus or minus the root of b square minus 4ac all over what? 2a. And in this case, our a is 1, our b is 2, and our c is 10. Now, imputing those values, we're going to be having minus 2 plus or minus the root of 2, which is the square root of the square of 2, which is 4, minus 4ac. 4 times 1 times what? 10. So we're having minus 40 over what? 2a. Sorry, our a is what? 1. So over 2. Now 4 minus 40, we are going to be having what? Minus 36. And square root of minus 36 is 6 I. But also this 2 plus what? This. Now this minus this is going to be giving us minus sign inside square root. So what this means is that we're going to be having an imaginary what? Number. We're going to be having an imaginary number. This minus sign here, those are going to be having an imaginary number. Anytime you see minus inside a square root, it means that definitely you're going to be having what? Imaginary number. So the square root of 36, we have 6. So our answer is going to be what? 2 minus 2 plus or minus 6 I over what? 2. The I is because of the minus. Now from here you can then have that minus 2 plus 6I over 2, or minus 2 minus 6I over what? 2. 2 cancelling both sides, so we're going to be having minus 1 plus 3I, or minus 1 minus 3I. So you also how I got this 2 divided 2 1, 2 divided 3, and 2 divided 6 3. So that's it. So we have gotten the poles of our what? Closed loop configuration. So that's all for this video. Subscribe, like, share if this was helpful, and keep being the best version of yourself. I know one day our country will be great. See you in the next video. Goodbye.